All right, guys, so what we're going to start with for section 5.7, this is about the binomial theorem and Pascal's triangle. There you've got a picture of the triangle, but you do not have to memorize it. It is real easy to recreate. And if you look, some of you can see behind my bookshelf here, there's the top half of the triangle behind it. I had it hung before I put my bookshelf in place because I didn't know I was going to have the bookshelf. Back here, the one behind me. So you can see, I don't know how many rows of it back there, but like I said, it is super easy to recreate. Okay? Pascal's triangle always starts out with a 1 on the top row. Then, every row after that is going to start with a 1 and end with a 1. So I've got a 1. My next row starts with a 1, ends with a 1. The next row starts with a 1, but we need to talk about where this 2 comes from. You're going to add these numbers, and the 2 goes right between them. And then it ends with a 1. On the next row, I start with a 1, add these 2, gives me 3. Add these numbers, gives me 3, ends with a 1. The next row starts with a 1, add these numbers to get 4, add these numbers to get 6, add these numbers to get 4, and it ends with a 1. And you just continue that pattern. Now, you can continue this pattern forever. I've just given you through row 5. And while it looks like I've got 6 rows, the first one is numbered row 0. And let me show you how to know real quick and easy what row you are on. If you'll look at this diagonal right here, that tells you what row you are on in the triangle. Now, what are we going to use this for? Well, if they ask me to expand m plus n to the 4th power, you've got to know that means m plus n times itself 4 times. And you can multiply it the way that you already know how. And we're going to do that first. But then we're going to use Pascal's triangle to do it a little bit differently and get the same answer. And then you can decide which way you like better.
Okay, so where did...
Okay, so the 10s came from, let's start here. I start with a 1, add these numbers to get the 5, add these 2 numbers to get 10, add these numbers to get 10, and add these to get 5. Now, if I wanted to do one more row, let's just do one more here together. It's going to start with a 1. I've got to add the 1 and the 5 to get a 6. Add the 5 and the 10 to get a 15. Add 10 and 10 to get 20. 10 plus 5 is 15. 5 plus 1 is 6, and then it ends with a 1. So you see how you can continue this pattern forever if you needed a higher row number, okay? And that one is row 6. So now, let's do m plus n to the 4th the way that we already know how, okay? I'm going to start out by just multiplying m plus n times m plus n. Okay, it's just FOIL or double distribute, whichever one you like better. Okay, when you get that one finished, double check it with mine up here. You know if you have questions about it, because then I have to multiply m plus n times m plus n again. And I don't want to redo all the same work, so I'm just going to use the answer I got the first time. Now, is everybody good up to here? Okay. So what we're going to do next is we're going to take this m squared times everything in the green parenthesis. So that will give me m to the fourth plus 2m cubed n plus m squared n squared. Then I want to take the 2mn times everything in the green parenthesis. So that is going to give me 2m cubed n plus 4m squared n squared plus 2m n cubed. Okay, and guys, if I miss a number or miss an exponent, please let me know because it's very easy to do in a problem like this. Now distribute your n squared to everything in the green parenthesis. And that's going to give me plus m squared n squared plus 2m n cubed plus n to the fourth. Combine all of your like terms. All right, so this is what I get when I fully expand that. Now, I want to show you how this relates to the triangle and how to get to the shortcut from this. Okay. This was an original to the fourth power, right? Take a look at the coefficients that are on row 4. 1, 4, 6, 4, 1. Look at the coefficients in our answer. 1, 4, 6, 4, 1. Then let's look at our exponents. Starting with your m. I have an m to the third, m to the fourth, n to the third, n squared, m squared, m to the first, and I don't have an m over here. Then going backwards the other way, I start out with my n to the fourth, n to the third, n to the second, n to the first, and no n. That is what we are going to do to use the shortcut. Okay, so here's what I've got to do. I'm going to start out with my coefficients that come from row 4. Okay, because it's to the fourth power, I'm going to take these numbers out of the triangle, and I'm going to space them way out. Okay, so 1, 4, 6, 4, 1. Now, in my binomial, the first variable is an m. So I start on the left-hand side with an m to the fourth, and my exponents for m get smaller with each term. Now, start back on the right-hand side, and I'm going to have n to the fourth, n to the third, n squared, n, and because that was a plus in the middle, all of these are going to be positive. And isn't that the same answer I got doing it the long way? Okay. So, for this problem, this was much, much shorter. Okay, we're going to look at a couple of others, and then, like I said, you can choose which way you like better. The next one we're going to do has a subtraction in it. Okay, So I have x minus 2 to the 5th power. So I want to take the numbers from row 5 in my triangle.
Yeah, I see that's 5 rows, don't you think? You know?
Okay, so there are my coefficients. So now start with your x. On the left, we've got an x to the 5th, x to the 4th, x to the 3rd, x squared, and an x. When I work with this negative 2 to the 5th power, this is where it gets a little bit more complicated. I'm going to start here with a negative 2 to the 5th, and then I have a negative 2 to the 4th, negative 2 cubed, negative 2 squared, and a negative 2, and then I don't have a negative 2 to put here. Then I go back and simplify each term. So the first term is just going to be x to the 5th. For the second term, I have a 5 times a negative 2 makes that negative 10 x to the 4th. Now, for the next one, what is negative 2 squared? 4. So I actually have 10 times x to the 3rd times 4, which gives me a positive 40 x cubed. For the next term, what is negative 2 to the 3rd power? Negative 8, because negative 2 times negative 2 is a positive 4, times negative 2 again makes it negative 8. So this one is 10 times x squared times negative 8, which makes that term negative 80 x squared. For the next term, what is negative 2 to the 4th power? 16. So I have 5x times 16 makes that plus 80x. And then for the last term, what is negative 2 to the 5th power? Negative 32. And this is your expanded answer. So now, how many of you think you like this better? Okay. I kind of like it better because when I was doing this problem, I was really struggling to keep track of my exponents as well as the coefficients that I was multiplying. You know, if I've got something to the 3rd power, I might or might not do it the new way. But if I've got something that's a 4th power or bigger, I think the binomial theorem and the Pascal's triangle makes it a whole lot shorter. So here's one for you to try. Okay. So if you're good on the last one, go ahead and try this next one. I'm going to pause my recording, and I'm going to work it, and then I'll put my work back up here and let you check it, and then that's it for the day. We'll just practice some. Yeah, so guys, here's the part you've got to remember. When you have 3b squared, that whole parenthesis is squared. You have to square the number and the b, so you get 9b squared. And then you have 6 times 9 gives me 54, a squared, b squared. For the next two terms, you have to cube the entire 3b and take 3b to the 4th power.